You guys are awesome. Okay, so parametric equations. Okay, this is the second part to it. So let's take a look at some things. First of all, example 1 should be pretty easy, okay? So if we want to sketch x of t equals 3t minus 1 and y equals 4 minus t, then what we know is our start is at the point -1, 4, okay? Because what I want to do is show real quickly that we could rewrite this as a vector equation. So our vector equation starts with x, y equals, okay? And our constants are our beginning number. We would go with a -1 and 4. See the x values, y values. So I get an x of -1, 4 plus t times our movement. Our movement is going to be to go over 3 and then down 1. Our movement is going to be to go over 3, down 1. That's our movement. So it's going to be 3, -1. That's my vector equation. So the nice thing about the vector equation is it really kind of gives us an idea of where we're going. Okay, so if I'm going to go start at 3, -1, I'm going over 1 at 4. I might put my xy axis over here somewhere. So I might just, let's see, I'm going to put my x-axis here, about here. And I'm going to go, I am going to be going down, but over. Oh, shoot. I probably should have put it here. My bad. It's okay. I can erase that. I think I put it over here instead. I hate when I do that. I hate when I do that.
Why'd you draw a line?
Well, I need the xy axis, right?
Oh. Oh. That stuff smells really strong.
Yes. All right. -1, 4. We're going to go 3, -1. Okay, so start. I think I'm going to go right about there. Put my x at y axis right about there. So, let's check it out. -1, 4. Start right about there, okay? And then my movement is to go over 3, 1, 2, 3, down 1, okay? Over 1, 2, 3, down 1, 1, 2, 3, down 1, 1, 2, 3, down 1. So it's going in this direction, okay? And one of the things I like to do is I like to put the time. Okay, so I graphed it. I know I'm going to start at -1, 4. And then my movement is to go to the right 3, down 1. To the right 3. So that's my movement. That's called the velocity, okay? So my velocity is the movement, okay? We talked about that on Friday, and that's at 3, -1, okay? So I like to put in the time, t0, t1, t2, t3, t4, okay? So we need the first 5 seconds, so I'm going to do one more. I'm going to go 3, 1, 2, 3, and down 1. So here's my first 5 seconds, t equal t5, okay? So if I ask for the first 5 seconds, I've got t0, t1, t2, t3, t4, t5. And I like to put the arrows in on it because it shows the direction it's moving, right? Okay. That's it for number 1. It's not that hard, right?
Yeah.
You got to know where to start, and so I rewrote it as a vector equation. You use the regular, you use your numbers, your constants as your beginning point, and you use your numbers in front of t as your movement, okay? All right, number 2. Okay, if I'm going to graph x equals t squared minus 3t and y equals t minus 1, I'm going to use my calculator, okay? It says use my calculator, so I got to be a little bit smart on my calculator, okay? So, again, same thing. If I go to my mode, I've got to make sure I'm in degree mode, parametric. I don't think the degree makes any difference though in this case because there's no sine or cosine, but we definitely need to be in parametric, okay? So for sure, parametric mode. Again, the degree or radian mode does not matter in this case because there's no sine or cosine to graph. Okay, so I'm in parametric. I go to my y equals, clear that old problem out, clear, clear, and let's type it in. Yeah, let's just type it in. So we're going to type in my t squared minus 3t, and I'll type in a t subtract 1. Okay, and I'll wait for you, okay?
I have a question.
Yes.
How do you get the T thing.
Make sure your mode, let's go back to the mode. It's pair.
Is X.
Okay, and then, yeah, okay, is that what you guys are saying?
Alpha.
So, yeah, Simon, you've got right here x, t, theta, n, right? So it depends on what mode. So, for instance, if you tell the mode that we're in parametric, it'll automatically pop up t. If you're in function, it'll automatically pop up x. If you're in polar, it'll automatically pop up theta, right? Okay, now, I need to think about this. I'm going to graph. So this is probably like a regular graph. So when I go and I do my window, okay, window. Let's check out the window, okay? So 0 to 4 is fine, but steps by 0.1 is fine. But let's think, if I'm going to do a regular graph, x min, maybe, I don't know, maybe negative 10 to 10. What do you think? Negative 10 to 10, like regular graph. Regular graph, negative 10 to 10. Negative 10 to 10 on my window. Okay, so my window, I'll go t equals 0 to t equals maybe 4. And then my x min, I'll probably do a negative 10. X max to probably a 10. I'll do the same thing with y min 10, negative 10, and my y max probably 10. Okay, so I'm just trying to set up my calculator because I think it's going to be a regular graph. Looks like it might be some kind of a parabola maybe, right? So okay, it's in my calculator. Give me thumbs up when you're ready for me to graph it. I'll make sure everybody gets that in, okay? There's the window I would use. However, I'm going to show you something in a moment because I'm going to change the time on it, but I want you to see why I'm going to change the time on it, okay? But everything else looks pretty good. I will change the time. I'll change the T0. I'm going to go back in time, but I want you to see why before I change the T0, okay? So if I graph this,
Boomerang.
yeah, it looks like what I'd like to do, and if I use my trace button real quick, at 0, I'm right here. There might be more graph. There might be more graph here, right? There might be more graph here. So what I'm going to have to do is go to negative time to get this graph here. Does that make sense? I'm going to go ahead, because if I plug in 0 for 0 seconds, I'd get us right to the point 0, negative 1. But if I need the graph over here, I'm going to go back to my window. I'm going to go maybe negative 4. Negative 4 times. So I'm going to go back in time to see the back half of the graph, which is weird. Back in time to see the back half of the graph, but I'm going to need to do that. Okay, now let me graph it. Okay, there it is. Okay, even better. Now, I might want to go a few more seconds to see the rest of this, right? So let me add more time. So I go back to my window, maybe add, I don't know, instead of 4 seconds, I'll go 6 seconds, right? And let's graph it. Hey, it looks like a sideways parabola. You know, it's kind of a big deal because here is a graph that we could not graph before. A sideways parabola you were not able to graph on the calculator because it's not a function, right? It's not a function, but we were able to graph it today because, check out our mode, we're not in function mode. If we're in function mode, you could not graph this equation. But in parametric, you can, and that's one of the advantages. Now, if you're going to take calculus, if you take calculus, you're going to get all sorts of weird graphs, I mean really weird graphs that are not functions. One of the tricks you can do is you can actually find out what they look like in calculus, these weird wavy things, doing it in parametric. If you can see the graph, it's going to help you a lot. This is what I had to do when I was in school. I'm like, okay, well, I don't know what this thing looks like. So I'd graph it in parametric. I'd be able to check it out, and then I'd know where certain things were, like the vertex, right? Because you can't get that from this equation. Okay, now, example 3. So obviously it's a sideways parabola. You guys agree? If I graph it, I graph this thing, it looks something like this. I'm going to just do a sketch of it. Okay, it looks something like this, right? Well, that's not a function. But what we want to do is put it in rectangular form. So I want it in terms of x's and y's only. So let me take my original x equals t squared minus 3t, and I'll take my y equals my t minus 1. And when I want to put in rectangular form, I want to make sure it's written only in x, y terms. No t. No t. Okay, so I got to change these two equations into one equation, x's and y's. So here's what I'm going to do. If I solve for t, solve 4t. I'm going to do that right here. I'm going to bring over the 1. Y plus 1 equals t, right? And then I can substitute. Okay, if I solve for t, then I can substitute. I can put this y plus 1 in there and in there. And then all of my t's will disappear, right? The t's will disappear, and I'll have it in just terms of x's and y's, which is what I want. So I'll say, all right, x is now equal to parentheses y plus 1 squared minus 3 times a y plus 1. Okay, now that is correct. I'm probably going to do something more with it. I'm going to probably simplify it. But all of a sudden now it is into rectangular form. Okay, that is the answer. I'm going to tidy it up, make it look nicer. But that is the answer, x and y's. No t's, right? So if I simplify this a little bit, I'd have x equals, let's see if I FOIL this, y squared plus a 2y plus 1 minus 3y minus 3, okay? I just did a little foliage in my head. I knew that y plus 1 times y plus 1 is y squared plus 2y plus 1. I just did that in my head. Okay, I just did that right there, okay? And then simplify this a little bit. I'd have x equals a y squared minus a 1y minus 2, which is a sideways parabola, isn't it? That would be a sideways parabola because of the y squared, which is exactly what we have here. Okay, and you're going to have to do this. And this is not that difficult. The trick is, if you want to get rid of the t's, you have to solve for t and substitute. Okay, if you want to get rid of the t's, you're going to have to solve for t and then substitute, get out the t and then just simplify it, okay? Not too bad? Okay, all right, ready to turn the page? All right, example 4. Let's graph first x equals cosine t sine t. Now, question is, do you want to do degree or mode, degree or radians? Does not matter to me, but we're going to have to use one or the other. Okay, degrees, radians. Degrees, radians. Let me see, show of hands. How many people say degrees? It doesn't matter. Degrees. How many people say radians?
Yeah, radians.
Okay, I guess degrees win. Doesn't really matter.
Thanks, guys.
You want to do radians? I don't care. Okay, so if we're going to use degrees or radians, I'll just do degrees. Then we have to make sure we go back to our mode, right? Make sure our mode's in degree mode. Make sure we're in parametric, okay? And of course, I'm going to go y equals now. And clear. And I'm just going to type in x equals cosine t and sine t, right? All right, now, I always like to think about my window. Let's always think about our window. Now, if we're going to go degrees, let's go window. Okay. So, time. We're going to go all the way around a circle, aren't we? And you guys chose degrees. So let's go 0 to 360, okay? Steps by maybe 1. Negative 10 to 10, negative 10 to 10 is probably going to work, okay? Probably, okay? And 360 might be way too many seconds, but, you know, we'll check it out, okay? You guys ready to graph it?
Looks like we should zoom in a little bit.
Yeah, I agree with you, and we will. Totally agree. Totally agree with you, okay?
It's a Stewie's head.
Yeah. So, yeah, it looks like a circle, doesn't it? You guys agree? Looks like a circle. So, if I want to zoom in, I'll just change my window real quick. How about if we go from like maybe negative 2 to 2?
It's like a QT orange.
Negative 2 to 2, okay? That would zoom it in quite a bit because, you know, I think it was only a radius of 1. That looked like...
Or you could hit zoom 0.
Yes, yeah, or zoom fit. There's lots of things, yeah. Graph again. Okay, there it goes. So it's graphing 1 degree, 2 degrees, so it takes a little while, but it is a circle, and we've talked about the fact that even though it looks like an oval or an ellipse, it really is a circle. It really is a circle. Okay.
It does look like Stewie.
Yeah.
Look what I ended up.
Okay. So, what's the equation? So if I want the equation of it in rectangular form, I go ahead and graph my line in. I might make this be 1, 1, 2, 3, 4, 1, 1, 2, 3, 4, negative 1, 1, 2, 3, 4, negative 1, and then I'll just draw my circle, okay? How am I doing? Alright, I'll wait for you.
Can I see your window?
Yeah. Yeah. Show my window. There's my window. 0 to 360, because you guys said degrees. And what we found out is when we first graphed it, it was really itty-bitty. So then Nikolai said, well, let's just bring it in. And I thought, okay, good idea. Let's bring it in. So instead of negative 10 to 10, it's like little. I went from negative 2 to 2. Okay, brought it in, right? So you can see it better.
What's your y max?
It'd probably be 2. I'm just going to negative 2 to 2. And do you know why I chose that? Do you know why I chose that? It looks to me, when I first graphed it, like the radius was 1. Look, a really itty-bitty circle, didn't it? So I just changed my window so I could see a better picture, okay? Yeah, and then, of course, you guys have that window in? So I put my graph. And the cool part about the trace button is if I go to trace, I really want to tell you something I think is kind of cool. So at any time, we can tell where it is. Okay, so just think about this. Just fathom this question. You happen to be a nuclear physicist. You happen to be a nuclear physicist, right? And you happen to be down in the Silicon Valley, and there's this big, gigantic donut building. It's called a cyclotron. You ever heard of a cyclotron? Yes. And literally, they like to smash atoms, right? They might want to know where that atom is at any particular time. You think they might want to know where it is at any particular time, so they could smash two atoms together to create something cool, right? So this could be an example of my little atom cruising around my cyclotron, getting ready to smash into another atom, so they can tell where it is at any particular time. That might be important to these guys. What do you think? Because if the two atoms miss each other, time to go home. Try again tomorrow, huh? All right. Now, what's the equation of this? This should be an x squared plus a y squared equals 1. Hopefully everybody knows the equation of a circle. You guys agree with that? X squared plus y squared equals 1. That's the equation of a circle in rectangular form. That is the equation of a circle, of that circle. X squared plus y squared equals 1, radius of 1, right? If you don't know the equation of a circle, I'll put it up real quick. Equation of any circle should be an x minus h squared plus a y minus k squared equals r squared. Okay, that's the equation of a standard equation of a circle, okay? And our center is at 0, 0, right? Our center is at 0, 0, and our radius is 1, okay?
Wait, what's that for?
That's the equation of a circle. That's standard form of a circle. That is the equation of a circle, which we've talked about before, but I know. It's easy to forget things. Okay. All right. Example 5. All right. Consider x equals y squared plus 4. Okay, so I kind of know a little bit about this. If this were an x squared, it would look like this. If this were an x squared, it would look a little bit like this, right? But since it's a y squared, I know it's going to look like this. Okay? And I can't graph that on my calculator unless I change it to parametric. So it changes to parametric. Let's do this. So parametric has got two equations, right? It's got an x of t and a y of t. Okay? Parametric has both x of t and y of t. Okay? So if we let y equal t, then let's rewrite this as a, not y squared, but a t squared plus 4. And we can put that into our calculator, right? Now again, we're probably going to have to play around with the window. Okay, we got to check the window. So before you do a whole lot of craziness on this, we can graph it, and then we better check our window, okay? So let's go back to y, clear, and I'm going to put my t squared plus 4, and I'll do my t, okay? So if I let and do everything in terms of parametric, then I can graph this thing, okay? I can. Window, if I go to my window, man, I went from 0 to 360. That's way too many, huh? How about 0 to maybe 4? How about negative 4 to negative 4? Now, why would I want negative 4 to negative 4? So I can see the back half of that graph. Steps by maybe 0.1 so I can see more of it. Think about a normal graph. I might go -5 to 5. And I might go -5 to 5. You want me to write down my window for you? Okay, here.
Just leave that up there.
Yeah, I can leave that up there. Okay. So I went -4 to 4 on my time, because I want to see the back half of the graph. And I went -5 to 5, -5 to 5, because I kind of really know I kind of got a really good idea of what the picture looks like. And I can adjust my window after I graph, okay? Yeah. Is it a bad window? Okay, I'm going to know that in a second, okay? So I'm going to graph it. It is. So that's all yet. So what do I need to fix my window? I think the time's okay, but I need to go that way, right? So let's fix our X max, right? So I agree with you both. Yes, so I go to my window. Let's change the X max to maybe 10.
It doesn't, it's the same thing. I just read it.
Hit the graph button.
1 million.
That's pretty good. Not bad.
Go
I mean,
15.
Okay, we can go 15. I can do 15.
Don't do 1,000. That's a little bit too much.
Well, yeah.
I checked this.
Okay. And I can even, if I want to play around, I can do my trace button, find out where it is at any potential. So 20, I can tell already. I can tell by this right there that 20 would be as far out as I could go, right? Unless I added more time. If I added more time, I can go further out, okay? All right, now. Number 6, graph R equals theta in parametric mode. Okay, now first of all, R equals theta. What's that going to look like? Well, we know that R, what do we know? We know R is equal to X cosine theta, or R is equal to Y sine of theta. Okay, remember those from polar, right? So if we need parametric, we got to have an X and a Y, right? So I can rewrite this instead of R. I can rewrite this as a X cosine theta for my R1, and I could write it as a Y equals sine theta because that's R for both, right? And R is equal to X and Y. Okay. So if I graph that, that's just the same circle we did up there. I won't put this one on the test. This one's kind of complicated. All right. So I know that you're not doing homework a whole lot, but